Hello, dear viewers, you are welcome once again. The just ended proof was to show that log x base 1 over p is the same as negative log s base p. And we chose to represent that expression by a variable y, which was never part of the proof. What if you don't want to use any variable? The proof can still be successful. So let's look at an alternative where we show that log s base 1 over p is the same as negative log s base p. In doing that, the only thing we need to do is to know how to change base of a logarithm. For instance, in our equation here, that is the expression of the logarithm given to us here, we can see that the base is 1 over p. To show that this expression is the same as negative log s base p, I would like to change the base 1 over p to p. And in doing that, we wouldn't need any external variable to prove that this expression is the same as negative log s base p. So let's change the base. Changing the base of a logarithm log s base 1 over p is a matter of looking at the log number x as numerator and log base 1 over p as denominator. Then since my preference is on the p, I would then choose p as my base of the logarithm. Depending on the proof that you like to show, you can go for any base that you want. And in this case, my preference is on the base p. As you can see in my equation here, what I'm supposed to arrive at, the base is p, so I'm going for base p. Okay. If, however, we again say that if you have challenges in writing a log expression to change the base, that one too, you can inbox us so that we can have one-on-one tutorial with you to show why and how logarithm base can be changed like we have shown here. Okay, so now that log s base 1 over p has now been written in a form such that the base is now p and the s is now a log as a numerator and the 1 over p is now a log as a denominator, all having base p, we can then move on. What else can we say? Let's look at the denominator of the log expression here. You can see that, of course, the denominator is log 1 over p base p now. So let's try to write the log number 1 over p in an exponential form. In doing that, we arrive at log x base p still as numerator untouched. Then we come to the denominator and we have the 1 over p now written as p to the power negative 1. Okay, so now we have in the denominator log p to the power negative 1 base p. You agree with me that we can write this expression in the denominator such that we can apply the third law of logarithm, that is exponential law of logarithm, so that the negative 1 will then come to multiply the log of p base p. Okay, if that is okay, then we can go on by showing that applying the exponential law of logarithm in the denominator here, you have the exponent of the p, which is negative 1, multiplying the log p base p, as you can see here. Let me space this expression a little bit to show the different lines. Okay. Sorry. All right. I wish I could space it a little bit further. So I will then use my enter key to space the week. Now I think it's okay now. Okay. So now we have -1 log p base p. Again, we've come to a point where we have log p base p as an expression that we will agree that it will go to 1. Just as you said in the previous video, anytime that we have an expression like log of a number with a base being the same number, that goes to 1. So this whole expression log p base p will definitely go to 1. Okay. So if this whole expression will go to 1, then our next step is likely to be log s base p all over -1. Why? Since this is 1, we have 1 times -1, and that is -1. So at this time, I think you've seen that it is now possible to conclude. It is now possible to conclude that any number divided by -1 is that same number negated. So our proof is now successful if we conclude by saying that the log expression given to us as log s base 1 over p is then now the same as negative log x base p as required, because the -1 is dividing the numerator log s base p, as you can see here. Again, thank you very much for your time. If you have any questions or comments to make, please try and subscribe and inbox us so that we can have one-on-one discussion on your comments or questions. Thank you and goodbye.